is mostly based in structural patterns, growth and development as a part of the diagnostic to analyze what are the factors that are not properly aligned, what is the discrepancies that's creating structural factors. The cervical span, the alignment, and the vertebral space give us great information about the stability of the craniocervical region. Also is related with pain and discomfort that the patient is relating, and then we can see the misalignment into the vertebrae and how some of the vertebrae are rotated. Also, we analyze the hyoid bone position because the muscles attachment, it will create forces that will create discomfort into the patient. The facial growth vectors and analysis is really important to understand what is the part that didn't develop properly, and to visualize it better, we take the teeth out of the equation so we can analyze that the patient has a lack of development of the middle face. That is the reason that the patient has an occlusion class 3 and the situations that we find into the data collection. Here we can see into the x-rays how the septum is deviated, the airway. We analyze in all the 3 different planes of the space the anatomical conditions and the relations into the occlusion to make a full comprehensive analysis. The cervical component is fundamental for the craniocervical stability. We analyze the teeth, the wear facet, the grinding, and we can see if the patient is a clincher or grinder and where the teeth are touching, the contacts, the body talk. So the wear facets give us good information about what is the stability and what is the parafunction of the patient. Here we can see the relation of the arches, and now we proceed to analyze the motion. Into the motion, the axiography has a specific frequency. We see opening and closing, and we pay attention to maximum opening and the closing event to see how is the stability of the joints in reference with the occlusion. The measuring point always starts in habitual bite because it's the reference that we utilize to take the CBCT to see the anatomical structures, what allows the segmentation to be able to recreate the motion in 3 dimensions and to be able to make an analysis that not only relate the axiography, also give us the connection, what is happening directly into the teeth, and the relation to have the different possibilities of an analysis between the traces and the anatomical structures. We can isolate the traces, we do opening and closings, we see how is the vector in opening, the arch of closures and the dimension, the lateral excursive movements. We pay attention what happened with the bending angle with the chief side and what is the stability. We don't make any mathematical calculations. Technically, everything is based in observation. What I think in this point can be a key with the technology that we have these days that allows to visualize everything and make a more comprehensive analysis. In the series of the axiographies, we make joint congruency tests. We make exaggerated movements to see how is the behavior in the joints. We utilize also an helicoid that is a device biconcave that allows to glide with force and see what happened with the joints when it's making excursive movements in presence of something between the teeth that execute a vertical dimension. Phonetic patterns are really important to determine mostly the F sound and the S sound. The F sound has the tendency to have the lip interposed, what distalize the mandible the most, and the S, the more protrusion sound. We analyze the inclination of the occlusal plane based in function, not in mathematicals or in any type of cephalograms. Technically, our concept try to take the most advantage of the analysis, visual analysis, to make conclusion, what is the behavior, or what is the more sweet spot where we can start treating the patient. During the process, we utilize transelectrical neural stimulation for over an hour, and we relax the musculature. And we want to see what is that congruency point in XYZ mode that is involved in the muscles. And we relate it also with the incisal protrusive to be able to make a graphic that let us see the projection of the trajectory. We take multiple bytes, tens bytes, and we see and we measure into the axiography that these points are really congruent. The most important of this is that we take multiple data, we take this information, and for here we can export this information to another software to make overlapping of the files to make a different analysis. With the tens byte, we see that the projection can create different vertical dimensions in one path of trajectory that can be correlated with the analysis into the axiographies into the different planes. But this vibration creates an involuntary motion that makes us not have any kind of manipulation into the patient. The models in these positions in specific that we export for the module tracker. Now we're going to bring it to the Mnemotech softwares and we're going to be able to create what is called relations. With these relations, every single byte registration that we took into the axiography, now we can make it part of the digital planning in Mnemotech. We can make the full import of all these mandibular positions, and we can rename it depending on the events that we have. We create meshes that connects the joints with the lower teeth that allows to have comparison between all these mandible positions that we took as a previous records, and we have the capabilities to compare them into the x-rays to evidence the changes that we have from the starting position. That's why the starting position need to be in habitual occlusion, that is the pathological occlusion, that is the point of reference where the teeth get together, and where we collect all the information to analyze the pathological bite, and from there to find different options of mandible positions. Here, all the colors demonstrate a different bite registration. Most of them, they have specific conditions, different vertical dimensions, and we start removing the layers that it has more joint compression from the back to the front until we get to a position that it will give us a vertical dimension that can be used for digital planning and predictions, and the other one that we're going to utilize for the orthotic. This is the part of the orthodontic simulation that we use to analyze the amount of rapid expansion that we'll need, what can be the amount of spacing, and how we're going to validate the new mandibular position in reference with the proper intercuspation. This allows to visualize the occlusal plane, the inclination of the roots, and what is going to be the mechanics that we're going to use during the Mu technique to establish the proper balance and restore the physiological aspect. All the principles has to be involved in how to recuperate the proper face and appearance and the proper function.